right. Well, good morning, good afternoon, everyone. Welcome to day 3 of the NYOUG Virtual Lunch Hour Training Days Conference. Today's focus is on Oracle performance, and we've got sessions by Oracle Aces today, Sean Scott, Gary Gordhammer, and Janice Griffin. Tomorrow, we're going to have PL SQL sessions by Ask Tom's Chris Saxon and Oracle's Jeff Smith. So if you're interested, definitely sign up. A little bit about the New York Oracle Users Group. It was founded in 1984 for the exchange of ideas, assistance, and support among Oracle users using Oracle software products. The organization consists solely of volunteer users, consultants, and vendors of Oracle-related products and services. You can get individual, corporate, and educational or nonprofit memberships, and more information for membership can be found on their website. Connect with NYOUG on Twitter, Meetup, LinkedIn, Facebook, or nyoug.org. They have sometimes multiple webinars a month, and you're always welcome to join the ones that are Viscosity and NYOUG together. Otherwise, I think you might need to be a member. Maybe you don't. We'll have to ask Coleman later. All right, so this week's conference is sponsored by Viscosity, Quest Software, and Incorda. My name is Monica Lee. I work for Viscosity North America as their marketing director. We are a full Oracle stack consulting firm, core expertise in Oracle database. That includes RAC, Oracle Apex. We do zero downtime migrations, performance tuning, anything with high availability. We've got decades of experience with infrastructure, including engineered systems. And we've been most recently upgrading most of our customers to Oracle Database 19c. And we host monthly workshops and webinars through orapub.com or with user groups like NYOUG. All of this week's sessions are recorded and they will be shared through nyoug.org or at orapub.com. As of the start of the year, Orapub is now powered by Viscosity. It was founded by Craig Shallehammer, Oracle ACE Director, who is now part of the Viscosity team. So we're super excited about that. You can join as a free member there and get access to tons of sessions and webinars like this on demand. So look for a follow-up email later today or tomorrow by my colleague, Katie Barnes. She'll have more information for you of how to access slides and recordings from today. All right. You're probably familiar with Quest Software. We're going to hear from them later today between session 1 and session 2. But right now, I've got Patrick from Incorda, who's going to tell us a little bit more about what they offer. And I think he's going to give us even a little demo. So Patrick, thanks for joining us.
Thanks for having me. And hello from rainy New York City here. I know it's virtual, but I think everyone's probably looking at the same gray sky I am. So today's day 3 of Incorda, kind of talking to you guys. And I think you've heard my colleague, Ryan Garrett, give some slides. I've given some slides as well. And so here on day 3, with the theme being performance, we thought we'd just say, you know what, like, let's stop killing you guys with slideware about what Incorda can do. And let's just actually show it to you here in like a quick 5-minute demo. So just as a refresher, you know, what is Incorda designed to do? It's designed to get your data out of really complex ERP systems like your Oracle EBS, your Oracle Fusion, Demantra, you know, transportation management, what have you, and into an analytical form without having to go through the data warehousing and data modeling and RPDs and all of the stuff that can take up a lot of time from a implementation perspective, right? We want to get you guys moving as quickly as possible and getting down to the insights that you can get from your raw data. So today here, I'm actually showing the Incorda UI. This is from our cloud infrastructure where I've spun up an instance in our cloud, and I have a whole bunch of data loaded from Oracle EBS. So a lot of Oracle folks on the phone, you're probably pretty familiar with this. One thing to keep in mind is Incorda is great for all kinds of data: Salesforce, NetSuite, SAP, homegrown databases, you name it. But since we're talking to Oracle folks, we figure we're keeping in the Oracle in the Oracle realm here. This is a subset of what we call our EBS AR blueprint, accounts receivable blueprint. So for those of you familiar with EBS, familiar with accounts receivable, a lot of these table names are going to be pretty familiar to you. So Incorda brings that data over in its raw form, in that third normal form, in that transactional form, and allows users to still operate over that data, ask questions of that data without impacting the source system and without having to do that modeling by having that data reside in our engine. We support full and incremental loading. So you do one big load and then update your data every 5 minutes in Incorda. And we've taken lots of customers from, the problematic daily ODI Informatica refresh process down to fresh data in front of their business users every 5 or 10 minutes. So this is Oracle EBS AR data. And with the theme being performance today, I chose this particular instance because I got quite a bit of data in here. My transaction lines is about 470 million rows of data. My payment schedules is 170 million rows of data. Overall, inside of this, what we call a schema, essentially where we loaded data from EBS, is about 2 billion rows of data. And so what I'd like to do here today, I'm kind of just showing you all the numbers here. If I sort by number of rows, you see I got 470 million, 300 million, 170 million. I want to actually show you how you can go ahead and explore that data right off the bat. So I'm going to click the Explore button here, which launches into Incorda's visualization building experience. Now, Incorda's engine speaks SQL. So if you're a SQL nut, you can write SQL against Incorda's engine. But for the purposes of illustrating what Incorda can do today, I figured I'd just go ahead and build out a table that aggregates all those transactions up by, let's say, by sales channel and party type, if you're familiar with Oracle EBS. So I'm going to take the revenue amount, the quantity ordered, the quantity invoiced. So 3 pretty key metrics when it comes to AR. And I'm going to go ahead and aggregate those up by sales channel. And let's say party type or something like that. So you can see here, I'm building a visual right now, almost like what you do in like an Excel type format. But the difference with Incorda here is all of this is happening on the fly. If you're familiar with these EBS tables, it's actually quite a lot of data. And you can see here, Incorda is actually answering this query, these 4, bringing data from these 4 tables into a single visualization for a user to go ahead and interact with. If I want to go ahead and say, well, hey, Incorda, that's cool, but show me the SQL. I can click the SQL button up here, and it's actually going to show me exactly what Incorda's engine is doing on the fly. And if you try to do this in an Oracle database, I know there's a lot of good performance gurus on the phone here today. You're trying to join a 500 million row table, a 100 million row table, a 75 million row table, and a 160 million row table all in a single query. It's probably not coming back with sub-second performance, right? You're not going to be able to interact with that data. If I click save here and save this into a new Incorda dashboard, click save. I'm going to have the ability to interact with this data on the fly. So you can see here right away that dashboard paints. It goes across all of that data set, and everything I see here is fully interactive. If I want to go ahead and just only see partner programs, for example, I click that, I drill immediately all the way down to that level. And if I wanted to say, get a transaction level view of that data, I can just drag in a flat table to that same dashboard, click save. And now I've gone down from 471 million transactions down to 1,031. If I back out of this, if you look down at the bottom of the screen here, 471 million transactions. All of this happens across the raw data in Incorda without impacting the source system. And if you think about what this allows you to do, you're all of a sudden your end users now have transaction level data. They can get there by any kind of drill path they want. It's completely arbitrary, and you don't actually impact the source system at all. This is not data virtualization or materialized views or anything like that. This is all happening inside of Incorda. So this is just a small sliver of what we can do from an Oracle perspective, AR, and even a subset of AR. But when you think about blueprints, we have kind of the whole, all the modules across Fusion, EBS, NetSuite, in terms of the Oracle ecosystem. So hopefully that was helpful. Again, my name is Patrick Rafferty. I'm the global head of pre-sales at Incorda, and I'll put my information in the chat. If you'd like to reach out to me after the session, that'd be great. And as always, you can go right to Incorda.com and spin up a trial instance for yourself and kick the tires on Incorda on your own. Thanks.
Thank you so much, Patrick. And thanks to Incorda for sponsoring this week. Our first session of the day is by Oracle Ace Sean Scott. I do want to remind everyone that this is a live webinar. We've got great speakers for you today, so please take advantage of asking them questions, even asking our sponsors questions. You can submit those in the Q&A box. Speakers will likely get to them at the close of their session. So if we go over time today, just know these are recorded. You will have access to all the recordings. We'll get you the slide decks. I know those are always your first questions, so don't worry, we will get you everything we can. But definitely take advantage of the Q&A box. I can never say that enough. It really is just a great opportunity to have all of these technologists with us today. So without wasting any more time, let's get to the good stuff. Sean, it's all yours.
Great. Can you hear me?
Yep, sounds good.
All right. Excellent. Well, I'm coming to you from sunny and windy Idaho, and the wind is blowing all of the clouds very, very quickly eastbound. So I think that New York is probably going to get some more clouds if this is any indication. All right. Well, thanks for the introduction, Monica. Just switch over to my, there we go. All right, real briefly about me. My name is Sean Scott. I've been working with Oracle Technologies since 1995, and Oracle ACE, and Oracle Certified Professional Cloud Architect and DBA. And I've presented in the past at Open World, Collaborate, and multiple regional user groups. I started out as an application developer and kind of fell backwards into being a database administrator. Ran my own database consultancy for a number of years, and a good chunk of my career has been spent on operations and database reliability engineering teams. I work a lot with RAC, data guard, sharding, partitioning, the engineered systems, and the whole suite of Oracle diagnostic tools, including Autonomous Health Framework, Trace File Analyzer, and GIMR. Professionally, for Viscosity, I design and I build disaster recovery, site reliability solutions, work with upgrades and migrations, implement cloud solutions for customers. I'm a DevOps practitioner. I write a lot of automation, supporting infrastructure as code, data as code, containers, virtualization, do a lot of Bash, Docker, Terraform, Ansible, Python, so on and so forth. Today, I am discussing the Grid Infrastructure Management Repository, or the GIMR. And I want to start out with an overview, and then we'll dive into the details. And the first thing that we're going to talk about is the GIMR database itself. So the GIMR database is a separate repository of diagnostic and performance data for clusters, and additionally or optionally our RAC databases. And it stores the information that we need to detect, to identify and diagnose problems in cluster targets. It also contains some modeling information it uses to recommend corrective actions when it detects problems. And when a GIMR is while GIMR is a database on a RAC system, it doesn't require very much administration at all, and it's automatically monitored and managed by the cluster for us. So it doesn't require a whole lot of effort on our part. Now, going back to the very, very early days of GIMR, it used a Berkeley database. Since 12.1, it's a container database with a single pluggable database, and there's no extra licensing required for GIMR. It is part of RAC itself. The database and its listener will run on one node in your cluster. It automatically relocates if it fails or if the node stops or crashes. By default, GIMR is going to save its data into your OCR or voting disk group. It stores its data in partitions and it automatically cycles through them. So the GIMR database is going to be a fixed size according to, and that size is based according to the number of targets that you monitor and the amount of time that you want to retain that monitoring information for. And we can set all of those limitations. We'll get into that a little bit later in the conversation, talking about how we set and define those boundaries. The GIMR database itself is a repository for a whole host of diagnostic information that we collect on rack clusters, including the real-time performance monitoring data that we get from the Cluster Health Advisor, the metrics, the fault data, and the diagnostics that we collect through Cluster Health Monitor, events that are logged by the grid infrastructure through the alerting and logging system, and then workload and CPU architecture information that's generated by Oracle's quality of service management tools. And then we also access the GIMR through tools like Autonomous Health Framework, Trace File Analyzer, from Enterprise Manager, and the OraCheck, ExaCheck utilities, and Oracle Fleet Patching and Provisioning references information about the cluster and some system metadata from the GIMR database. So you can see it's a pretty important, pretty integrated host of information that we use for a lot of our diagnostics, a lot of our alerting, and so forth. Some new features that we see in 21C and beyond. These are some really neat features that I'm looking forward to personally. The first is we can now separate the cluster telemetry from the data store and preserve access to diagnostic data, even if the cluster is offline, freeing up resources. So we now have this ability to have just a single centralized GIMR database, not having to have one on each cluster. So that central database allows us to have one place where we go for that information. If your cluster should go offline, you can still access your GIMR data. You don't have to worry about managing and configuring, and we'll talk about configuring and setting up monitoring, especially for CHA a little bit later. You don't have to do that on each individual cluster if you've got a large repository. So that's something that I'm really looking forward to myself. And that, of course, means that if we have a remote GIMR repository, that we must be able to install GIMR separately. And that is a new requirement, in fact, for 21C, that you have to have a separate GIMR home for your GIMR database. So if you are installing 21C, the clusterware, it's going to ask you for the location of that new GIMR dedicated home. And if you're upgrading from an earlier version, it's going to ask you to specify that new GIMR home so that you can move that GIMR database into its own software installation. And so this is going to provide us with a number of advantages, potentially faster, less problematic patching, better upgrades, but it does mean that we're managing a new home. Hopefully in your environment, it's just going to be a single database home for the GIMR database, but we don't have to worry about problems with the GIMR during patching and upgrade and so forth. And then the final 21C innovation is that you'll have the ability to run limited cluster monitor OS diagnostics on individual nodes, even if GIMR isn't installed. So we'll talk a little bit later about the Oracle Cluster Monitor, or the OCLU Mon utility. That prior to 21C is a GIMR it requires GIMR for you to run it in your environment. With 21C and beyond, even if you don't have GIMR installed, you'll still be able to run those OCLU Mon diagnostics to collect operating system information, even if GIMR isn't installed. Okay, some real quick FAQs, some questions that people often have about the GIMR database. Cluster health is not tied to the GIMR database. So if the GIMR goes down, the local or the cluster, if the GIMR goes down, the cluster is unaffected by that. So there's no relationship between those two. If for some reason the GIMR database does fail, we have clients on each target in the cluster. They will continue collecting information and caching that data on the local node for us, so we don't lose information should the GIMR database fail. If you are running on a system where you have huge pages available, You definitely should use them. Having that information cached in memory is going to mean GIMR is more reliable and resilient and performs better. It requires about 371 to 379 huge pages, depending on the version that you're running. I think in 19C, it's 371. But again, it's a small number of huge pages for a big benefit that you get from them. There's no separate patching that you need to perform in versions prior to 21C, because all of the patches are included as part of either the grid infrastructure release or the grid infrastructure patches that you apply on the system. And finally, there is no need to perform any kind of backup of your GIMR database. Again, this is just a series of partitions of performance data that cycle through. It's a fixed size. If for some reason you want to archive your cluster performance data, there is an ability to do that through the cluster monitoring utility, the OCO-UMON utility. And that is something we would do if we were going to perhaps move our cluster data to a new home, or if we needed to recreate the database, we can preserve that data through that OCO-UMON utility. A question that people often ask is, why does the management database name start with an underscore and the management DB PDB, why does it start with a dash? Well, it is actually a protected character that you shouldn't have as part of your database name or your pluggable database name. And those protected characters, those leading protected characters, prevent tools like the database configuration assistant, the upgrade assistant, network configuration assistant, auto upgrade, and so forth, prevents those utilities from accessing the GIMR database itself, which would potentially change the database and affect its reliability. So the only tools that we ever use to connect to the GIMR database are dedicated management database configuration assistants and other dedicated utilities that we have for the GIMR database. For those wondering about disk size, I mentioned this earlier. These are our minimums that I'm showing you here. These can be larger based on the amount of time that you want to monitor the database or the amount of time you want to retain GIMR information for. I think that these numbers represent a 72-hour cycle. So in 12.1, it was 5.2 gig for the first 5 targets that you monitor, 500 meg for each additional target. With 12.2, it went up to 36 gig. On 19C, it's 28 gig for the first 5 targets, and then 5 gig each for all additional targets. Fairly minor by modern standards. So that is the GIMR. Now I want to talk about something that's closely tied to the GIMR, and that's the Cluster Health Advisor. The Cluster Health Advisor uses the GIMR database, but I find that very few folks are aware of CHA or CHA. I'm just going to call it CHA from here on out. Very few folks seem to be aware of CHA and what it can do for you as a DBA. So it was first introduced in 12.2. CHA is a monitoring component. It's enabled by default, and it's going to automatically monitor the operating system on all of your cluster nodes as soon as a rack database is started. So if you don't have a rack database running on a cluster node, it's not going to monitor that node for you. It doesn't automatically monitor your rack databases on those nodes. So even if you've started a rack database on a node, it's not going to automatically monitor that rack database. And this comes back to that target monitoring, where we want to be conservative on the amount of space that we use. So if you have a rack database or an instance running on a node, you need to go in and specifically, deliberately enable the monitoring. And this lets you selectively monitor the instances that you want to monitor in your cluster environment and prevents over collection, let's say, of diagnostics, perhaps for nodes or databases that aren't that important to you. CHA or CHA is also integrated with Enterprise Manager, and there are some additional scripts and tools available for visualizing the CHA metrics that CHA captures. The overhead for the Cluster Health Advisor is low. It accesses all of its OS information directly from memory. And it's going to start that collection, again, immediately once a RAC database starts. However, you're not going to see that. I should have mentioned this before. Monitoring for RAC 1 node has to be explicitly enabled. So if you're running a RAC 1 node system, it's not going to automatically collect those OS statistics like it will for a regular RAC node. The ASH data that CHA collects is also read directly from memory from the SQL management repository without making any kind of database connection. So these read from memory features, they're going to reduce the overhead on your system and conserve resources, and it lowers the impact that CHA has on your system. But the real benefit from this comes because if the database hangs or the listener fails, CHA is still going to be able to collect those performance metrics from your database even when those regular database connections are unavailable or if they're disabled for whatever reason. As for what it collects, over 150 different signals per second for each target that it monitors. And then it takes that data from each node, it synchronizes it across your nodes, and then it smooths the results into 5-second chunks for reporting purposes. As far as what those metrics are, it's checking RAC events, it's checking host resources, IO performance against a catalog of known problems, and then it's going to generate alerts and recommendations for you to address any issues that it identifies on your system. Now, when it comes to alerting with CHA, it uses a somewhat different monitoring or alerting system than what you might be accustomed to. So we're typically using threshold-based monitors where we set an upper limit or lower bound, and we get an alert whenever that limit is breached. So with those absolute limits, we get absolute alerts, even if sometimes we look at that and go, yeah, that's okay. Instead, CHA uses what's called a normality model, and it looks at load and it looks at activity in your system in a more conditional sense. So what it's doing is it generates predictions for your system based against historic loads. It takes into consideration the time of day, it takes into consideration the duration or the frequency of these different signals, and how all of these different metrics are interconnected. So a simple threshold-based monitor might trigger and generate some false positive for us if they don't have a wide view of the system. And what I mean by that is, let's take, for example, we have an Exadata system. We have multiple RAC databases running. So maybe we have 4 RAC databases running on a single Exadata. We have instance and we have database-based monitors. They have a limited visibility on the overall system activity. They can only see the individual database. So during a busy period, we might have, say during a financial close, a lot of IO activity taking place or a lot of batch reporting that's being generated. And if that's on another system and it's loading IO on the system as a whole, an individual database threshold might see that and go, oh no, my IO rate has gone down or my response time has gone down. Well, with CHA, on the other hand, it has this global perspective of the total system health, and it's capable of recognizing this pattern based on past performance and models that we build, which I'll discuss in a little bit as well. It sees that and it understands, all right, the system is very heavily loaded by one database, which means we can expect things to be a little bit slower for other databases as well, and it's not going to generate an alert for you on that. Something else that maybe you might overlook about this normality model is that if we take that same system during a lull in activity, say Sunday morning at 4 a.m., nothing's running. But Shaw looks at that and says, you know what, I see that maybe there's some unusual performance or resource consumption on this system. And even though load is really low on this system right now, that shouldn't be performing as slowly as it is, or it shouldn't be consuming as many resources as it does. And so with a threshold-based monitor, if we were to look at that, well, it's all below the radar for that threshold-based monitor. But Shaw looks at that and says, no, this isn't right. Based on my normality model, it should not be performing this poorly, even though it's within our KPIs, even though it's below our alerting thresholds, it's going to notify you of a potential problem. And if that problem developed during a lull in processing, well, it may be 3 or 4 or 5 hours before it becomes critical as load increases on the system. With Shaw, it's buying us that additional time to get in there to diagnose and fix that problem before it becomes critical during a higher load period. Okay, I was talking about models here. Out of the box, Shaw comes with 2 default models. One is for the cluster, and one is the default model for our database. And both of these models make very conservative assumptions. They're simply baseline models that are only going to flag the most critical issues for you. And you can certainly run your system, your CHA, under these default models. In fact, most people are probably running under these default models because they don't recognize that there are options here. But you need to understand that those defaults give you a really wide lane to run your database in. So if we want to narrow those diagnostics down and get more accurate results, more accurate predictions and alerting, we need to calibrate the cluster health advisor for our systems. So to do that, we want to identify at least a 6-hour window of representative workload for the database model. For cluster monitoring, we want to select a time period that covers a typical workload on all databases in a cluster. So going back to that Exadata example where we had 4 rack databases running on a single cluster, we would define models for each of those individual databases based on when their typical load is, but we would define a cluster model against the cluster as a whole when the aggregate or the average activity of those 4 databases is, we'll say, representative or indicative of the level of activity that we want to monitor. So I'm going to talk about calibration in just a moment, but what I want to first do is go back to GIMR and cover a few do's and don'ts for our GIMR databases. So GIMR gets a lot of grief. It was not a well-received product when it was first introduced, and it has been really difficult to shake that negativity that has followed GIMR around. And I've done this presentation a few times in the past, and I've had people in person, I've done this presentation, and I start talking about GIMR, and there are people in the audience that just like, they shake their heads and they look down like, oh yeah, I hate that thing. This is so stupid. Why am I here? Let me assure you, GIMR is a vastly improved product. If you had a bad experience with it in the past, I hope that you will give it a second chance. And I don't work for Oracle. I'm not saying, oh yeah, please use our GIMR database. It has gotten better and it really offers you a lot of benefits. If you are not currently using GIMR and you're not using it based purely because somebody else said GIMR sucks, I really encourage you to take a second look at it with an unbiased eye and see what it can help you with. Okay, so with that in mind, let's talk about some best practices. I'm not a big fan of the phrase best practices because it implies that there's a best way of doing things and a not so best way of doing things. But these are good things that you would want to follow in your environment for setting up GIMR. So again, GIMR, self-managing, very little, if anything, you need to do with it manually. First and foremost, don't disable your GIMR database. Don't drop your GIMR database. It's an optional install in 19C, so you don't have to have GIMR in 19C. I encourage you to make sure that you do have a GIMR database and that you do install it. For one thing, Oracle support requires any tier 1 cluster running 12C or later, it must have a GIMR database to retain that tier 1 status with Oracle support. You will also be removing beneficial functionality from your system if you remove your GIMR database or if you disable your GIMR database. Next thing you want to do is, or that you don't want to do, don't connect to the management database using SQL+. There are no user serviceable parts inside the GIMR. The only time that you would ever connect to your GIMR database through SQL+ or through a client is under the direction of Oracle support themselves. And finally, don't try to manage any passwords manually. All of the GIMR credentials, they're all generated automatically by GIMR and Clusterware. They're synced by GIMR and Clusterware and managed in the background for you. If for some reason you do need to change the database management, or not the database management, if you do need to change the management database password, there is a dedicated utility, MGMT CA, that does that password management for you. Please do not use a database client because it's going to break some things for you. Do not add your management database or the management database listener as targets for Enterprise Manager. There were some old versions of OEM that auto-detected the management listener and the management database and tried to add them for you automatically. The newer versions ignore the management database, so you don't need to worry about that any longer. But if you do see those services somehow through OEM, do not create them as targets. It's all of GIMR is managed and monitored automatically by Clusterware as part of the grid infrastructure. Enterprise Manager is not going to recognize them properly. It treats them as single instance targets, and that can potentially interfere with how grid infrastructure manages and especially relocates your GIMR database in the event of a node failure. On the same vein, don't use server control to try and modify or manage the database, the management database either, or its listener. There are dedicated tools for changing, for managing the database, the credentials, and so on and so forth. That includes moving data files, adding, recreating the database. So don't try to use the traditional tools that you might use for a regular database. So that's a lot of do not stuff. It doesn't leave a whole lot for us to worry about, but some things that you definitely do want to do in your environment is use Server Manager to make sure that the GIMR is up and running, that it's healthy on your system, that the listener is up and running on your system, and that they're on the same node. And then one other slide here of do's for your GIMR database. Use a dedicated disk group for your GIMR data files. It doesn't need to be anything special. You can use external redundancy if you would like. There's no need to have it on a super high redundancy disk group at all. There's no reason that you can't, but it's not a requirement. There is this utility mdbutil.pl that allows you to move your data files. Again, don't try to do it manually. It's all built into that script for you. I'll cover that script in just a little bit. Ideally, set at least a 72-hour retention policy for your repository. We do this through the Oracle Cluster Monitor utility. It's a two-step process, though. First, you need to set the retention time, and you need to set the repository size to match. Now, the repository size, remember, is based on the number of targets that you are monitoring. So if you add a database later on, or if you choose to monitor additional targets, the size of your repository to capture that same amount of look back, that 72 hours, that is going to change. It's going to increase. So when you first set your retention policy in your GIMR database, if the repo isn't large enough, it's going to give you an error. It's going to say, I can't save that much for you because my repo is not big enough. And so that'll lead you going in and changing the repository size. Then you can change the retention time and everything will be good. But down the line, again, if you add targets, it's not going to give you an error to tell you that the repo isn't big enough. Instead, it's just not going to retain those 72 hours or however long you set it for. It's not going to retain that information for you. It's only going to retain based on the amount of space that's available for you. So you might get 48 hours or 24 hours or 8 hours. So if you go back and add new targets to your system, go through this process of checking your retention time and your repo size to make sure that you are indeed capturing the amount of historical information for CHA that you want to have. Which brings us back to the Cluster Health Advisor and the calibration process that I mentioned a little bit earlier. I've got a question here. We have 19 C clusters. Looks like the GIMR was removed by a previous DBA. Is there a way to install the GIMR? Yes, there is. In fact, I'm going to get to that. I've got a slide on that in just a few moments. We'll talk about recreating your GIMR database. Okay, let's talk about calibration. So one of the things that I love to do is cook. And calibration is, to me, calibration on your CHA is like me keeping my knives sharp. So I said before that there are a few shops that actually realize that CHA is available, and those that are using it, very, very few of them are going through the process of creating models and keeping them up to date with calibration. And that's fine. Again, those default models, they're going to get you by, but they're not going to give you the most accurate analysis, the most accurate reporting that you want. So in my kitchen, we've got a calendar in our kitchen, and I make notes on there. It says, yeah, take my knives to get sharpened. And every 6 months or so, I'll gather the ones that I use most. I have my favorite knives. And even though I sharpen them at home and I use a steel to keep them nice and sharp between sharpenings, I still take them over a couple times a year and I have someone sharpen them professionally. And every time I do it, every time I think to myself, this is really a waste of time. My knives are sharp. Everything seems fine. I don't need to do this. And then I get them back. And when I get those knives back, I forget just how sharp freshly sharpened really is, because on the way over, I'm thinking, yeah, these are sharp. And I get them back and it's, no, they were not sharp. The same thing goes for your Cluster Health Advisor. You are not going to regret going through this calibration process 2, 4 times a year, maybe 6 times a year, whatever works for your schedule, and including that as part of your regular maintenance. I guarantee you will not regret it. So I want to come back real quickly and talk about models. I discussed models a little bit earlier. Remember that CHA compares system activity against its models to identify problems in your system. And these models are learning models. So over time, they're going to adapt to the environment, but it's still not going to be accurate because CHA doesn't understand the context. So it just sees a database that runs 24 hours a day, and over time, yeah, it has peaks and it has valleys, but it doesn't understand the meaning of those peaks and valleys. So if you're running this without, or if you're running your system with the default models and not calibrating those models, CHA just assumes that everything is peak load. What we do with calibration is we say, this is normal. This period of time is our normal activity. Once CHA understands what normal is, then it can understand what is exceptional. So exceptional below normal, exceptional above normal. But we have to think, well, what is normal in our system? It's very conditional. What's normal for month end or year end probably isn't normal for a random Sunday morning in the middle of the month, or normal for your backup window. So what we can do is we can create multiple models for these different conditions, and then we apply them through a schedule appropriately to our CHA, so that now when we're in the midst of a backup, CHA says, all right, this is a backup window. And so I'm going to work with and consider load based on that model. Now we're in an overnight period where activity isn't that high. So I'm going to consider activity based on that model, so on and so forth. So now we can identify the different types of workloads that we have on each target. We activate a model that's appropriate to the workload, and that lets us cover all of the conditions in our system. And you don't have to be really, you don't have to go overboard on this. You don't have to have a model for, lunchtime and dinner time and breakfast and overnight and so on and so forth. You can certainly do that. You can certainly get really precise and have those narrow working sets that you apply to your environment. But really, you can probably get away with periods of load, periods of low load. All right, so calibration is going to run against the telemetry that we store in the GIMR repository. And this is a reason that you want to be retaining 72 hours worth of data, because you don't want to have to run calibration immediately after a high load period, anything like that. You want to be able to have a more relaxed approach to your calibration. So if you've got 72 hours or more, you can always go back and run that calibration against a period and say, hey, this is calibration or a model for, I don't know, your backup period, something like that. So when you're running calibration, you need to tell CHA whether you're calibrating for the cluster or whether you're calibrating for a database. If you give a new name for your calibration, it's going to create a brand new model for you. If you want to update an existing model, just recycle the name that you've used in the past. And then you give it a time range that you want to have it model against. And you can optionally specify what's called a KPI set. So a KPI set is something that sets some expectations for your target performance based on whether it's a cluster or database, and then by some further metrics. You're setting boundaries for each of these KPIs as sort of a training goal for the calibration. These are not thresholds that we're setting. Instead, try to think of them as desirable boundaries for each target. Remember, this is a learning model, and CHA may let one target exceed those boundaries minutely by a certain margin, whatever, provided they don't exceed them by too much or for too long, and provided that there is perhaps another metric that explains the excess in one area. So some tips for calibration. Again, we can create multiple models for our targets to suit our different local profiles. Be aware that if you create multiple models, that it's going to require some extra space in the GIMR as well. So if you're going to create a bunch of dedicated models for your targets, keep an eye on that GIMR space, keep an eye on your retention limits, adjust the size of your GIMR accordingly. So just go back to those commands that I've shown you a couple slides back. If for some reason you run a calibration and you get an error that says no sufficient calibration data, there are a couple of things that could be a cause for that. The first thing is your GIMR repo might not be large enough. So your time range that you specified might just fall outside the monitoring range that's available for you, or the retention range that's available. You can also see this error if you have just newly installed GIMR and it hasn't had time to collect metrics yet, or if you've started on a system that just hasn't had time to collect enough data to model. You want to make sure that your modeling window is wide enough. Try for 6 hours as a minimum typically. And if you set your KPI significantly wider than what's represented for your time period, you may see this error as well. So CHA is going to expect the KPIs to somewhat approach the system data. And if nothing really comes close enough, it may just look at that KPI and say, you set a boundary or you set a threshold for me to look at that's way up here, and things are just kind of constantly way down here. I don't know what to do with this. And so it just kind of throws its arms up and says, give me something else. Let me try again. So once you have a model built, what do we do with it? Well, we can query that model, or we can query our target against the calibrated model. So calibration queries run against the telemetry data that we have in our GIMR repository. And this is another reason that we want to have a retention period that's long enough for us to go back and look at something, especially if we're looking at something as part of a postmortem for a problem that we encountered. So again, make sure that you've got some retention or some retained data that you can go back and look at. So when we run a calibration query, it's going to generate a report for us for the target that we asked for against the model that was running at the time. And if we give it a time range, we'll give it a time range to query against, and we also want to give it an interval, and that interval is going to define the granularity of the analysis for us. The output for a query or a calibration query is broken up into these little individual intervals. So if you have shorter intervals for a long period of time, it's going to take a lot longer to generate the report, and the report is going to be much longer, but it will be more detailed. You can also query KPI sets to narrow the results based on specific metrics. So we don't have to look at everything that was produced in the, or everything that exists in the GIMR database. If we know that we're looking at maybe like IO reads, you can go in and you can say, I want to look at the IO reads for the KPI metric, give it some minimum and maximum boundaries, and that'll refine your report for you. These are the same KPI options that are available in the model, but they don't have to match the KPIs that were in the model itself. So in the query, these KPIs are filters. They don't change the KPI in the model. In the model, however, when you run the calibration, those KPIs are performance objectives. So they're the same values, they're the same options. You can use them in both the query calibration and the calibration themselves the same way, but they have different results whether you're querying or whether you're calibrating. Couple quick tips for running your calibration queries. Make sure you set a time range. If you don't give it a time range, it's going to look at everything in your target data. It will probably take a long time. Again, larger intervals are going to run faster, but they will smooth out and maybe cut the smaller peaks off of your variations on the system. So you might not see so much of the spikes in activity is present in a report with a longer interval. But again, a shorter interval is going to take longer to run. And they can take a while to run. Don't be surprised if they take 20 or 30 minutes, even an hour to finish. What I typically do is I'll run these in the background and then capture the output to a file so that I can review them at my convenience a little bit later and not have to sit there and wait for them to run. If your GIMR is not hooked up to Enterprise Manager, or if you're not using Enterprise Manager, well, we run this query and so forth. What do we do with it? How can we visualize it and see some of the diagnostic recommendations that CHA produces for us? Well, if that's the case, we have this query diagnosis command. Query diagnosis is going to analyze our target performance against the model it was running, and then it's going to write all of these diagnostics to our GIMR database. And this query diagnosis lets us pull out and see the exceptions and the recommendations that GIMR is making for a given target and a time range. So we do that and we give it the name of an HTML file. And when it's done running, and this runs pretty quickly, we'll get an HTML file that looks like this. And so here you can see this report lists the events for each of our cluster targets. It gives you a legend, and it gives you a description, a cause, and an action for you to take for the various problems that you see in this report. So you can use this report for remediation. You can also use this report to adjust your KPI sets so that you're training your calibration models a little bit better as well. And this is an example of what you would see for a database target. So here we see a number of different problems that the GIMR has identified on different PDBs in this environment, and gives some recommendations. All right, the question about how do I create or recreate a management database after it's been dropped or disabled? That is the MDB utility, the management database utility. So this utility lets you check the database and listener status, and then it does the work of creating or recreating your management database for you, and allows you to relocate your disk groups to a different disk group if you would like. So there really isn't a whole lot to this. You can download this utility from My Oracle Support. It's a Perl script. In fact, this is the document ID 206-5175.1. That's the MOS note where you download this. There really isn't a whole lot to this. It's just this handful of commands. We can check the status, and we see here management database is not configured and the listener is not configured. So we'll just go ahead and we'll add the database. So we use this add MDB flag, and then we give it a target. We tell it what disk group we want to store the data on, and it goes through and it does all the work for us automatically. And then if you want to move your data to a different disk group, you just use this MGMT DB, the move management database disk group, and just give it the target location that you want to send the or relocate the management database disk group to. All right, some quick tips for working with GIMR. Some of this gets into the why people didn't like GIMR at first. The very first implementations of GIMR used Berkeley DB for the repository. That database could get pretty large at times, could grow unchecked. It wasn't cluster aware. So if GIMR failed over from one node to another, it created a brand new database on that new node. And so you could have a bunch of fairly large databases and Oracle DBAs. We'd look at that and go, I have no idea what this BDB file is. They weren't easy to manage. It became a mess. So if you've upgraded grid infrastructure from an older version, there's a good chance that those files are still there taking up space. You can safely remove those artifacts. Just make sure that you look on each node in the cluster, because they, again, could exist on any and every node in your database cluster. If for some reason you want to go in and you want to look at the trace files, this is one that I always seem to forget, even though I've been using Bash for years and years and years now. If you notice, the database is prefixed with a dash. If you want to be able to read or operate against any of those trace files, Bash is going, or your script, your operating system, your host operating system is going to read that dash as a reserved character. It's going to think that you're trying to set a flag or an option in your database, or I'm sorry, in the operating system for your command, and it's going to fail. So if you just prefix it with this /, then it's going to understand that you're referencing a relative path to a file, help it understand that the dash is part of the file name, Again, this is one that I always forget. And if I'm ever going in and looking at these, I'm like, yeah, wait, what do I have to do for this? Oh yeah, /. If you are running the Oracle Cluster Manager utility and you get an Aura 28000 error, it is probably the result of an incomplete GI installation or a bad upgrade, something that that failed at some point, or it could potentially be the result of a failed attempt to drop and recreate the management database itself. If that's the case, just rerun the management database configuration assistant and use it to update the OCR wallets. Again, I said, don't ever, ever, ever try to connect to your management database by using the command line through SQL+ through a regular database client. But if you should, for some reason, want to do that, you have to connect to sysdba in SQL+. You set the SID by prefixing it with a \, and then you can do SQL+ /as sysdba and get that OS authentication. So that's the trick. I included a quick glossary here of different commands that are available in GIMR. I'm not going to go through these individually, but these describe the different things that you can do with the different commands. And I thought this would be helpful for you to go back and you can take a look at these if you want to see what the different commands are and what's available to you. This one especially, the getting the diagnostics from OCL-UMON. This is the dump node view that's going to generate CPU and operating system statistics. And again, this is the dump node view is the utility that is available now on 21C, even if GIMR is not installed in your cluster. So a couple more options here for your OCL-UMON dump node view. And that's it. I've got a question here for the GIMR. When you run out of table space, if not SQL+, how would you increase the data file or table space space? So GIMR works a little bit differently than what you would see in a normal database. The GIMR data is a pluggable database. It is partitioned. And so each collection is part of a partition in that GIMR database, and it retains a certain amount of data, retains a certain amount of diagnostic information or data for your database. And so if your, let's say that your GIMR database is 5 gig and you're saving 72 hours worth of information. Well, if you add a target to that, you should increase the size of your GIMR database. But if you don't, what GIMR is going to do is it's just going to truncate off the oldest partitions until it has enough space in the GIMR database to hold the information for both targets. So you don't have to increase the size of your GIMR database. You don't have to manage the table spaces manually. But the consequence of that is that you won't be able to retain as much history. So that comes back to, in fact, let me slide back and see if I can find this here. I think I was talking about it where, nope, it's further than that. So that comes back to here. So this is this OCL-UMON manage repos where you'll check the retention time and you'll change the repo size. So what you're doing here is you're saying, this is how big I want my repo to be, and this is how much data I want to retain. So you don't have to worry about your table space sizes or anything like that. Again, it's managing partitions. GIMR takes care of that partition pruning automatically for you behind the scenes, but you do, and I really want to emphasize this, you do need to make sure that as you adjust targets, as you add models to your environment, go back and check the retention time and the repo size and make sure that you are indeed able to save the amount of information that you think you're saving. The consequence of that is that if you do run into a problem and Oracle support asks for some CHA diagnostics from your cluster, that are, I don't know, 36 hours old, and you're only holding 24 hours because you thought you had enough space, that information obviously isn't going to be available to you. So just keep an eye on your retention time and change repo size. Okay, another question here. Regarding the GIMR, after installing 19C grid, we noticed huge trace files being written under grid base, CRF, probably config tool logs, management CA. These trace files were filling up our file system. So we had a cron tab cleanup script. What is the management CA generating these very large trace files? I don't know. It could be something specific to your system. What I would suggest is if you're getting really big trace files like that under the management database, file an SR with Oracle support and say, I've got these really big trace files that are being generated. It seems unusual. It's filling up our diagnostic destination, and have them take a look at those trace files and see what the root cause is for that. Okay, and that does it. If there are no other questions, if you do come up with questions down the road, feel free to reach out to me on any of these avenues. Thank you everyone for attending today, and especially New York Oracle User Group for hosting the event. I hope that everyone found this worthwhile. And again, if you have questions down the road, feel free to reach out. Thanks so much.
Thank you so much, Sean. As always, it's such a pleasure to have you speaking to our followers and NYOUG members. If you have questions for Sean, even over the next 2 hours, feel free to drop them in the Q&A, and I can always send them over to Sean, who is one of my colleagues. I'll
stick around.
Okay, awesome. So he can also respond to you chatting back in the Q&A. So just direct your message to Sean if you have something for him.
I'll heckle Gary.